If you're not in a comfortable place right now, go ahead and get comfy, maybe grab a drink, sit back, and relax. Because we're about to embark on an endless journey together. And by the end of this video, there are only two possibilities: either you'll completely forget who and where you are, or you'll discover your true self. Are you ready for a journey of existence? Subscribe, and let us begin. According to the latest estimates, the universe is about 46 billion light-years in diameter and was born roughly 13 billion years ago. If you're wondering how something that old can be 46 billion light-years across, that's because of the expansion of the universe. As we know, the universe has been expanding and accelerating for a very long time. So, the speed of light isn't really a limit for the universe itself. We could talk about that more later, but for now, let us focus on scale. When we say 46 billion light-years, it sounds big, sure. But truly understanding or visualizing such distances is incredibly hard. So today, we'll make it tangible. We'll try to grasp how vast the universe really is. And at the end, we'll talk about why it matters. If you're ready, let us begin. Let us start from the 0 point, our home, this pale blue dot called Earth. In fact, we don't live on such a small planet. To make this concrete, if you got in a car and drove non-stop at 100 km/h around the Earth, it would take you more than 16 days. Too exhausting? Okay, take a plane, it would still take more than 2 days. So yes, our planet is not exactly tiny. For hundreds of thousands of years, we've been traveling, settling, living, and dying on this rocky world, and still, most people live their entire lives without ever seeing much beyond their hometowns. But our minds have no such limits, right? So let us leave Earth behind and head to our closest neighbor, the Moon. When we look at photos or animations, it feels like it's right there, as if we could just reach out and touch it. In reality, it's 384,400 kilometers away. If we built a road to the Moon and drove at 100 km/h non-stop, it would take us over 6 months to get there. Still, humans have been there. 12 people have walked on its surface. Incredible. But let us go further. When we zoom out a bit, we see the other planets. And while they look close in diagrams or animations, the truth is far from it. Let us take our car again and head toward the Sun. At 100 km/h, non-stop, it would take 177 years to arrive. By plane, still 19 years. So much for being close. What about Neptune, the farthest planet? That trip would take over 5,000 years by car, or 600 years by plane. See, even our own solar system is unimaginably vast. That's why even the idea of colonizing just our solar system is such a gigantic dream. We may not go ourselves, but our probes have gone far. They move much faster, tens of thousands of kilometers per hour. For instance, the Voyager spacecraft, launched in 1977, has been traveling through deep space for over 40 years. It left the solar system long ago in August 2012. And is now about 22 billion kilometers from Earth. If you could travel at the speed of light, it would still take 21 hours to reach it. You can even track Voyager's current position on NASA's website. Now, it's time to leave the neighborhood to go beyond our solar system. But where does it end? There's no clear answer. Some say it ends at Neptune's orbit, others at the Oort cloud, a vast shell of icy comets surrounding us. Depending on which boundary you choose, it would take 4 hours or a year and a half for light to reach the edge. To put that into perspective, light reaches the Moon in 1.3 seconds, and the Sun in about 8 minutes. Even at light speed, it would take over a year to leave our solar system? And we've barely moved a cosmic millimeter. Next stop, our galaxy, the Milky Way. The nearest star to us, Proxima Centauri, is 4.2 light-years away. If we drove there at 100 km/h non-stop, it would take 47 million years. By plane, 5 million years. Even at Voyager's speed, 73,000 years. Just to reach the closest star. Further out, the bright star Sirius 8.6 light-years away. Even further, systems of dozens of stars hundreds of light-years apart. If we keep zooming out, we find that our little local region, about 50 light-years wide, contains just a handful of nearby stars. Beyond that is something called the radiosphere. The bubble of space that our radio waves have reached since World War II. Those signals have traveled about 160 light-years so far. So even if there's intelligent life in the Milky Way, most of them haven't heard from us yet. And the Milky Way itself roughly 100,000 to 120,000 light-years across, containing around 400 billion stars. To grasp how big that is, imagine our solar system as the size of a coin. Then, the Milky Way would be about as large as the entire continent of North America. And on that tiny coin, our Earth would be smaller than a speck of dust. And on that dust speck, us. Let us go even further to Andromeda, our neighboring galaxy, 2.5 million light-years away. Beyond that, when we zoom out to 110 million light-years, we see the Virgo supercluster, containing thousands of galaxies, each with billions or trillions of stars and planets. And even that's just one among countless others. Go further still, and we reach the edge of the observable universe. A vast sphere filled with roughly 2 trillion galaxies. Yes, trillion. Each with billions of stars. This is what we can see. But the actual universe might be 250 times larger than that. Stretching hundreds of trillions of light-years across. Numbers so big they defy imagination. So, what's the point? Why does any of this matter? That's a deeply personal question. But for philosophers, thinkers, and scientists throughout history, this question has been the key to everything, because the quest to understand the universe is inseparable from the quest to understand ourselves. We are not separate from the universe. We are the universe. We are connected chemically, biologically, atomically to everything. This awareness can change everything. It reminds us to treat each other, and all life, with compassion and respect. Yes, we may seem tiny and insignificant. But we are also precious and extraordinary. Every atom in our bodies was once forged in the heart of a dying star. Knowing this shows how trivial our conflicts and worries really are. And how short and valuable our time here is. As always, until we meet again, thank you for being here. With love.